All right, guys. So tomorrow we're going to get into a new rule, and that is the quotient of powers. Now, if you think back to last semester, we did go over the word quotient. Quotient means to take, quotient represents the word division in algebra. So it's just another way of saying the division. Quotient is division. I'm over here questioning how I'm spelling. Division of powers. Powers. So when we're dividing, wow, that line is so crooked. Let me see. There we go. That's better. X squared over X, or it could be, my goodness, why is my everything going crooked? X to the power of 5 over X to the power of 3. Remember, a power is your base with the exponent. So when you're dividing two powers, the division of powers, what happens to the exponents though? So let's take a look. Here we have the expression of 6 to the power of 9 over 6 to the power of 4. Now we know that 6 to the power of 9, whenever we expand it, is multiplying that 6 9 times. And then 6 to the power of 4, multiplying that 6 4 times. Now, rules of cancellation, whenever you are using fractions, notice this created a fraction, we have fractions. Rules of cancellation, you can cancel the same base as long as you have one on top and the bottom. You can cancel this. You can cancel bases as long as you have the same base on top and bottom, not just the top. Okay. You can cancel, cancel bases when they're both on top and bottom. You can cancel bases when you have that same base on both the top and the bottom, not just the top. So if we look at this one, we can cancel. I would actually start with the side or the half where there's least amount of those sixes. So here, one on the bottom, one at the top, or one on the top, one on the bottom, one in the top, one in the bottom, one in the top. You have to cancel them out in pairs. Okay. Now I canceled 4 out here. I canceled 4 out here, but I'm left with these here on the top, 1, 2, 3, 4, 5. And that's where we got this from right here. 6 times 6 times 6 times 6. So we're multiplying the same base, which our base is 6, and we multiplied it 5 times. Now remember, you can continue to simplify this, and you could type it in the calculator, 6 to the power of 5, and you get 7,776. It could give you 7,776. It could give you both of these answers on the STAR test. So be able to recognize both of them. All right, next one, we have 100 to the power of 3 over 100 to the power of 2. Now 100 to the power of 3, meaning we're going to be multiplying 100 by itself 3 times. And then we have 100 squared. Rules of cancellation, if you have the same base on the top and the bottom, you can cancel it out. Top with bottom, top with bottom. Here, we were left with just this one lonely 100 here. So in exponential form, you write it as 100, or you could also write it as 100 to the power of 1. Either or, take your pick. Next, we have t to the power of 5 over t to the power of 3. I do not like using the variable t, but here we go. 1, 2, 3, 4, 5. Hopefully those do not look like plus signs. 1, 2, and 3. Here we go. So now we cancel as long as you have the same base on the top and bottom. Top, bottom. Top, bottom. And we're left with a couple of t's there at the top, t times t. And t times t gives us t to the power of 2, or t squared. So notice, once again, the base does not change, as always. I'm just going to write same base. But what happens to my exponents? Now, we've added before, so let's see. Let me zoom out a little bit so I can see both of them in the same screen. 9 plus 4 is 5. I mean, 9 plus, sorry. It's been a long day. 9 plus 4 is 13. It doesn't give me 5, but we know 9 minus 4 is 5. 3 plus 2 is 5. 3 times 2 is 6. 3 minus 2 is 1. 5 plus 3 is 8, not it. 5 times 3, 15, not it. 5 minus 3, 2. So here, when you are dividing two powers, you will end up subtracting the exponents. Once again, emphasis on the exponent. Remember, laws of exponents apply to exponents only. So when you're dividing two powers, base with the exponent, base with the exponent, division. When you're dividing two powers, you subtract the exponent, and you always want to subtract top minus bottom, okay? In that order, top minus bottom. Think of, and I always tell my students every year, which I think it helps, think of that division bar as a minus sign, m minus n, m minus n. I'm going to just write minus, minus. Okay. All right. So let's try this. Quotient of powers. This is it right here. Now we have the same base. Base stays the same. Let me zoom in because you're over here looking at that. Base stays the same. And we, subtract top minus bottom. So 7 minus 3. So we get 16 to the power of 4. Man, that looks like 164. Hold on, let me fix this. 16 to the power of 4. And 16 to the power of 4 simplified or reduced a little bit further, which I didn't do this before I started making my video. Ooh, 65,536. 65,536. Once again, they can give you this or this answer on the STAR test. Okay, let's look at B. We have the same base, but they're not in one single fraction. So it kind of makes it a little bit difficult. So I'm actually going to make sure that it turns into one fraction. In order for me to turn w to the power of 25 into a fraction, remember, we put a whole number or any singular number over a non-fraction over 1. Now, when we multiply, you multiply straight across. So 1 times w to the power of 25 just remains as w to the power of 25. And w to the power of 10 times 1, anything times 1 is itself. So w to the power of 10. Now it looks a little bit familiar, looks a little bit better. And I know that when we're dividing the same power, we subtract the exponent. So w to the power of 25 minus 10, top minus bottom. So we get w to the power of 15. Okay, hopefully pretty simple, pretty straightforward. Look at C. We have 1, 2, 3 of the same types of powers, But so I cannot subtract anything yet until I combine everything that needs to be combined first. So I have to combine these two at the top. Combine first. Now, this is the rule of what? Is it product of powers or power of a power? Is it the power of one power or the product of powers? Product of powers. There's two powers here. So product of powers tells us that the base remains the same and you add the exponents. Now I got to keep this 4 to the power of 5 before I ignore it or I forget about it. Now 3 plus 7 gives us 10. So 4 to the power of 10 over 4 to the power of 5. We're dividing two powers with the same base. So all we have to do is subtract 10 minus 5. And we get 4 to the power of 5. I'm trying so hard to make these look different sizes. Or we could simplify it a little bit further and it will give us 1024. Almost done. What about when we have a mixture, when there's more than one type of base? Notice you have fractions. You can separate these fractions. So what I'm going to do is I'm going to take one fraction one way and the other the other. So I'm going to grab this 3 and the 12, move it to the side. Now, would we be subtracting 3 minus 12? And the answer is no, because 3 is not the same size as the 5. 12 is not the same size as the 3. When we're talking about subtracting, we're subtracting the exponents. We're subtracting the smaller, or we're adding and subtracting the smaller numbers. These aren't small. These are regular integers, regular numbers. Okay. So since they're not coefficients, these two numbers or this fraction is not a coefficient. So you simply simplify. So simplify, or you reduce. Reduce if possible. So 3 over 12. How do you reduce or simplify a fraction in the calculator? All right, well, first of all, I'm going to do my alpha y equals 3 over 12. Enter, right? And we get 1/4. So this does change. It simplifies, it reduces to 1/4. All right, I'm going to switch to a different color. Now I'm going to grab this x to the power of 5 over x to the power of 3. I'm going to go a different way. X to the power of 5 over x to the power of 3. We're dividing the same base, so the exponent needs to be subtracted. 5 minus 3. And 5 minus 3 gives us 2. Once we're done simplifying, we put it all back together again. 1 over 4. X to the power of 2 is not in a fraction form, so technically it's considered to be at the top. You could put it over 1 just in case you forget, but you can also just leave it beside. And that's what I'm going to do here. I'm going to leave it beside that 1/4. Okay. Same thing here. It says, what if you have 2r to the 6 over 3r to the 4th? Okay, now we have that 2 over 3 out in the front. So 2 over 3. I try to type that into my alpha y equals, but nothing happens. So remember, you're going to simplify these if possible. So I'm going to put reduce. I forgot how to spell reduce all of a sudden. If possible. They won't always reduce, they won't always simplify, but you must try to reduce if possible. So that one didn't simplify, but now I'm going to take this r to the 6 over r to the 4th. I'm dividing two powers with the same base. So what do we do with the exponent? We subtract. So we get r to the power of 6 minus 4, and 6 minus 4 is 2. At the end, you put it back together again. So 2/3 technically that r squared can go there at the top with the 2, but I'm just going to leave it beside. So I'm not worried about, does it go in the top? Does it go in the bottom? Okay. And that is it for the notes. We'll do the other examples tomorrow and you'll work on your assignment. Have a great day.